students. The subject of this tutorial is pin diagrams. This is related to the Project Report Theory Chapter 2. You're in the design stage of your project now. You need a solution, and you need it fast. I developed this video to help you get started in case I cannot reach each and every one of you. What I've done here is I have placed some components on this board, and what we're going to do is we're going to puzzle it together. Now, each of these components, you should have the data sheet. I happen to know some of the information, so I will not spend time reviewing the data sheet. However, when you actually do your components, you have to have those key information right in front of you when you do this. The first thing that you need to know is a picture of your component. You need to have an idea of what your component looks like. Number two, you have to have readily available important specifications. The third thing that you must have is you must have a pin diagram. Pin diagrams tell you how you connect your components. And lastly, you have to have your pin definitions and the ratings for each of those pins. Typically, pin ratings include voltage level, current levels, minimum and maximum values, and some type of range. So, after that, you start putting your puzzle together. I have here 5 components. Here is an LM35 temperature sensor. Here is an analog to digital converter. Here is a basic stamp microcontroller. Here is a Darlington driver. I apologize for that. And lastly here is a relay. There's the coil, and those are the 2 switches. This driver here can sync or source up to 8 output loads. We only have 1. This is a serial analog to digital converter, which means that the input and output is read serially, which reduces the number of pins necessary. So the question becomes, how do I actually start combining components together? Where do I start? Well, of course, you need power supply. So somewhere you must know the power supply for your components. So down here I'll draw a power supply. And I need a value. Now I know that this Darlington can be used between a range of voltages. I know that this uses about 5 volts. This component uses about 5 volts. And this has a range between 4 and 20. And this has a range. So I'll use 5 volts as a common power supply because that's all I need, which means that 5 volts would connect to all of the VCC or every component. How do I know where to connect? I get that information from the data sheet. Now, if you look at these 2 components, you realize they do not need a power supply. They are actually components. And you have to understand how these components are used as an output. Basically, this is just a transistor. And you know that transistors have a collector, a base, and an emitter. Except these are called Darlington transistors. So, for the ground, I would connect the ground for each of the components. If you notice here, this component has two locations for ground, and both of them must be connected. I apologize. This here should not be connected at this point. It should be connected to VDD. And this VSS, there's the Maktoum bridge, goes to my ground. And here is a ground. Now, when you first get started, you want to realize that it's going to look messy like this. But as you move forward on, you will see that it becomes much easier. Now, basically what this chip is going to do is that it's going to sink a current from another power supply through the coil, through the transistor, into the emitter, which means one side of this coil will probably join to 5 volts. And the back side of this coil will be connected to one of the collectors. And then the base, I would select one of my outputs. Now my mic controller can actually control the output to this relay and turn it on and off. Here, on the input side, this chip has to communicate with this basic stamp. It does this by using the clock and the data. So that means I need 2 wires from here to my basic stamp. Those will be inputs to the basic stamp for operating this chip. Now the voltage from the sensor has to go to the analog converter. It so happens that the range of voltage out of this is okay. It's not the best. If I had my choice, I would use an amplifier. But for now, I will stick with something small, because the range of voltage out of this temperature sensor is very small. I will connect the input minus to ground as a reference of 0. This chip select can turn the analog to digital converter on and off. Since I'm going to be using this all the time, and I don't need to share this with any other component, I will simply connect this to 0 and keep it on all the time. Now, this is the kind of information that you would get by reading the data sheet. No one's going to be able to tell you this. You have to read the data sheet to understand the functions of all your pins. And you have to study it. If you want to write a good theoretical report for your project, you must understand how these components communicate with each other. So this could be one example of a pin connection or a solution of joining your components together. This component would read a value for temperature. And as the temperature changes, the voltage will change on the output. That would go into the analog to digital converter. At the request of the mic controller, it can read any one of these values at any point in time. How does it read the value? Well, this component here will change these analog numbers into binary codes, and it will read them as a series of zeros and ones coming out. And that could be the value of one of these analog voltages. And it sends it as a serial into this component here. This component here will decide whether that number that's represented by this analog voltage is perhaps greater than or less than maybe a set point that I have selected in the program. I may decide that if it is greater than a set point, then I would like to turn on this component here, which is a relay, and that relay could be used to operate a fan connected to its switches. Because the coil needs about 200 milliamps to operate, you need this component to supply the extra current. And that extra current is coming through the power supply into the transistor. This is the level of understanding that we would like. You need detailed information such as what is the minimum and maximum range of voltage? What is the speed? How is this communicating with the basic stamp? What's the criteria for turning the relay on and off? This is real theory at the electronics level. Thank you.